Hello everyone, welcome back to the channel. Today, I am excited to present ParkSense, Smart Parking Slot Indicator, an ESP32-based project designed to automatically detect whether a parking slot is occupied or available. This project demonstrates the practical application of sensors, embedded systems, and smart parking technology using simple and affordable components. For this project, we need an ESP32 development board, an HCSR04 ultrasonic sensor, a 128 by 64 OLED display, an LED, a 220 ohm resistor, a breadboard, jumper wires, and a USB cable. Now, let's begin by testing the ESP32 with a simple LED blinking circuit. To verify that the ESP32 is working properly, let's first build a simple LED blinking circuit. Insert the positive leg of the LED into the terminal strip connected to the resistor. Then insert the negative leg of the LED into the negative rail of the breadboard. Next, insert a 220 ohm resistor into the same terminal strip. Connect the free end of the resistor to GPIO 32 of the ESP32 and connect the negative rail to the ESP32 GND pin. Power the ESP32 using a USB cable. As you can see, the LED starts blinking continuously. This confirms that the ESP32, LED, resistor, breadboard connections, and programming environment are all functioning correctly. Now let's connect the HCSR04 ultrasonic sensor to the ESP32 step by step. Before connecting the sensor, let's prepare the breadboard power rails. Take a jumper wire and connect the 3.3 volt pin of the ESP32 to the positive rail of the breadboard. This positive rail will distribute power to the components connected on the breadboard. At this stage, only the positive rail is connected. Now let's take the HCSR04 ultrasonic sensor. As you can see, the sensor has 4 pins labeled VCC, TRIG, Echo, and GND. Let's start with the first pin, which is VCC. Take a jumper wire and connect the VCC pin of the ultrasonic sensor to the positive rail of the breadboard. This connection supplies power to the sensor. Once the VCC connection is completed, let's move to the second pin. The second pin is trig. Take a jumper wire and connect the trig pin of the ultrasonic sensor to GPIO 5 of the ESP32. This pin is responsible for initiating ultrasonic transmission whenever the ESP32 requests a distance measurement. Now let's connect the third pin. The third pin is echo. Take another jumper wire and connect the echo pin of the ultrasonic sensor to GPIO 18 of the ESP32. This pin sends the reflected signal information back to the ESP32. The ESP32 uses this signal to calculate the distance between the sensor and the object. At this point, 3 sensor connections have been completed successfully. The VCC pin is connected to the positive rail. The TRIG pin is connected to GPIO 5. The echo pin is connected to GPIO 18. Now let's complete the final connection. Take a jumper wire and connect the GND pin of the ultrasonic sensor to the negative rail of the breadboard. With the wiring completed successfully, the ultrasonic sensor is now ready to communicate with the ESP32 and measure distances accurately. Now let's proceed to the OLED display connections. Now let's take a look at the OLED display used in this project. This is a 128 by 64 I2C OLED display, which is responsible for showing the parking slot information in real time. First, connect the VCC pin of the OLED display to the positive rail of the breadboard. Next, connect the GND pin to the negative rail. Now let's connect the communication pins. Connect the SCL pin of the OLED display to GPIO 22 of the ESP32. Then connect the SDA pin of the OLED display to GPIO 21 of the ESP32. Let's verify the connections once again. VCC goes to the positive rail. GND goes to the negative rail. SCL goes to GPIO 22. SDA goes to GPIO 21. With these connections completed, the OLED display is ready to communicate with the ESP32 and display the parking slot status and distance measurements in real time. Now, Connect the ESP32 to your computer using a USB cable. As soon as power is supplied, the ESP32 starts running the uploaded program. The OLED display initializes automatically, and the ParkSense system becomes active. The ESP32 now continuously reads data from the ultrasonic sensor and updates the parking status on the OLED display in real time. With the system powered successfully, let's test the project. As you can see, the OLED display shows the current parking status. When no object is detected, the slot is marked as free. Now, when an object is placed in front of the ultrasonic sensor, the ESP32 detects it and changes the status to occupied. Once the object is removed, the status automatically returns to free. This process happens continuously in real time. Now that we have successfully tested the ParkSense Smart Parking Slot Indicator, let's take a look at the complete circuit diagram used in this project. The diagram shows all the connections between the ESP32, HCSR04 ultrasonic sensor, OLED display, LED, resistor, and breadboard. You can use this circuit diagram as a reference while building the project on your own. If your connections match the diagram exactly, the project should work as demonstrated. Feel free to pause the video and carefully examine each connection before proceeding with your build. The complete circuit diagram is now displayed on the screen. Thanks for watching. Like, share, and subscribe for more exciting DIY projects. See you in the next video.